We're going to turn our attention now to graphing a system of linear inequalities. As with graphing linear equations, we need to start by putting our inequalities in slope-intercept form. Let's look first at that green inequality. We need to reorganize the inequality so that y is by itself on the left-hand side of the inequality symbol. All of the other terms need to occupy the right-hand side. We'll start by subtracting x from both sides of the inequality. Now I have y is greater than 2x plus 5. Looking now at the blue inequality, we'll do the exact same thing. Again, our objective is to have y by itself on the left-hand side of the inequality symbol and all of the additional terms together on the right-hand side. We'll start by subtracting 2x from both sides of the inequality. Now I have negative y is less than or equal to x minus 1. Our last step will be to divide all terms in the inequality by negative 1. Now I have y is greater than or equal to negative x plus 1. Be careful here. Anytime that you divide or multiply by a negative, you'll need to reverse the direction of the inequality. This should read y is greater than or equal to negative x plus 1. Now we're ready to graph. Go ahead and hit y equals on your graphing calculator. We will enter these inequalities as if they were equations to start. In the line y1, enter 2x plus 5. In the line y2, enter negative x plus 1. Then hit graph. We see that the first inequality is represented by a boundary line with a positive slope and a y-intercept of positive 5. The second inequality is represented by a boundary line with a negative slope and a y-intercept of positive 1. What we don't have, though, is the shading appropriate for each of the inequalities. Let's go back to the y equals screen. For the first inequality, we would like to represent shading that is greater than or above the boundary line. Use your cursor to go all the way to the left. Once your cursor has selected the boundary line, hit enter twice. Notice now that you're able to see shading above the boundary line. Let's go ahead and hit graph and see what happens. The first inequality, the one with the positive slope, now shows shading above the boundary line, or y values that are greater than 2x plus 5. Let's do the same thing for the second inequality. Go back to y equals. Use your cursor to go down and then all the way to the left until you've highlighted the boundary line for the second inequality. Hit enter twice to select the values that are greater than or above the boundary line. Notice that you could continue to hit enter to toggle through other options. The next option, for example, shows shading below the boundary line. This would be for any inequalities that are less than or equal to the boundary line. We'll hit enter a few more times to select the correct boundary line. Once our shading is shown above, we'll hit graph again. Now, we have both inequalities graphed simultaneously. We see the solutions to the first inequality over here on the left-hand side of the graph, and we see the solutions to the second inequality over on the right-hand side of the graph. Notice this darker region, the region of overlap. This will be the solution set to the system of inequalities. The entire overlapping region would be the solution to the system.